Hello, everyone. My name is Robert Więcko. I'm operating officer at the Dashcore Group, and I have a real pleasure to open the first public
I think you're muted.
Oh, shit. Yeah. Okay.
Well, that went off to a good start, guys.
Now should be good.
Welcome to everybody on YouTube.
Yeah, hello, everyone. My name is Robert Więcka, and I will be your host and operator during the first meeting and first sprint review of the Dashcore Group. I have a pleasure to host the members of the team, and also welcome everyone on YouTube. I have a pleasure to. I want to point out that there will be a place for asking questions that we are going to answer at the end of this call. So if you are having any, please put them on the chat. With further ado, I hand it over to you, Maciek.
Hello, everyone. Sam, I guess that you wanted to bring some initial welcome.
Oh, I did, but Robert did it very well. So basically, we are going to. This is our first live stream sprint review. It is wonderful. It's wonderful to have so many people joining us. I did not expect so many, but that's really great. It is very raw in the sense that this is basically the very close to our normal sprint reviews. Over the last few months, they have been getting better and better. So we decided that it is time to open them up and share the work that we have done with the community. And this will probably be about 90 minutes. It might not be interesting as it is very technical to some people, but at the end we will be taking questions. It will be in 4 parts. First, we will do the protocol team. Then we will do the consents. Maciek, help me out here. Which one's number 2?
Yeah, sure. So maybe.
Oh yeah, it's GroveDB number 2, and then the SDK number 3, Tenderdash in last position, and in the middle there will be a demo and another presentation on secondary indexes. So we have a lot in store for you guys. With that, I will pass it on to you, Maciek.
Sure. Thank you very much. Thanks, Sam. And maybe a few additional words for that, because the platform project, we wanted to bring you guys some context of the platform project and how big it is already. All of those components that Sam mentioned, like the protocol part, which consists of Drive, DAPI, and other minor components. This has a dedicated team. Other than that, the teams are working on GroveDB, which is the hierarchical authenticated data storage, which is an internal part of the core platform components. Other than that, Tenderdash, the consensus engine, all of those areas have their dedicated teams with their own goals that come up to a common objective, common product objective that leads and drives the whole project up to further releases. And yeah, that's the case for now. The current objective of the whole platform group, the development group, is to bring up the version 0.22 on the testnet, which contains making GroveDB, the hierarchical authenticated data storage system, operational with the core platform service. And other than that, bring the DAPI SPV functionality on the SDK side. Sorry, I forgot to mention the SDK, obviously, which is also let's say a wide stack for the development of outside outside service, external services, and external applications on top of platform. For the scope of the release, in terms of the protocol part, the main pieces here were Masternode identities, which are developed because of the need of like each Masternode being properly rewarded by its services that they provide for keeping up the network. And I'm wondering, Ivan, do you want to? I guess that you want to say a few additional words about that with a technical explanation.
Yes, sure. Thank you, Maciek. So our first two tasks create system contracts on each chain and initialize system contracts in deployment tool. They were a requirement for the third one for create and update identities based on XML change. So I would better speak about the third one and go back to the first two. So the idea behind of Masternode identities is that we can pay rewards for L2 service for Masternodes. And since our currency on platform is credits, it makes sense to pay in credits, and identity is basically has balance. So the idea is to create automatically identities for Masternodes, and taking into account the reward settings and PROTX transaction. So there is a specialized system contract what we created. It calls Masternode reward shares, and this contract is used by platform to store information how Masternode owner wants to share rewards. So automatically we create the sharing information for operator, but Masternode can manually update the share information with the same documents, the same way how to use it other data contracts, and share the rewards with other identities. So basically it replicates the logic from layer 1, but also you can adjust it for you for L2. So in this task, we track the changes in DML, in SML in our case, and create or update identities and the related sharing information in data contract. And since we need to create existing to create identities for existing masternodes on an each chain, when we initialize the Genesis state, we need to have a contract, a Masternode reward shares contract there on each chain. But our previous system, how we registered system contracts, was a little bit complex, and it created we had a specialized tool to create these contracts, and they were created on the blocks when you run this tool basically, but we need this on an each chain. So we moved all creation, the creation of system contracts on an each chain as well. So now when we start the chain, all the required information and state it creates automatically by Drive, and you don't need to use any like additional tools and send contract IDs back and forth in SDK and everywhere. So right now we just to start the network, we just generate the keys for these contracts and pass these keys to the Drive, and Drive will do everything for you. So contract ID since this moment constant, and the same for all networks. So you don't need to update SDK and clients anymore. They will be like persistent. Yes, regarding the other protocol tasks, The first one is more like technical one. We just updated Dashmate and platform to the recent changes in Tenderdash. And then the second one, we had a feature flag to fix cumulative fees problem, what we had previously. And it's kind of breaking change. That's why we had the feature flag, and we tested our feature flags basically is this fix, and now it's not necessary anymore. So we just removed this legacy and left only correct code. That's it, I think. Thank you, Maciek.
Thanks, Ivan. So let's go to the next crucial area that was one of the main fundamentals of the scope for the upcoming release, which is our internal data storage system. And we'll go like a bit of top down, because firstly we will explain how this database is being used by the core protocol, by the core platform service, and later on we'll get to the details, the technical details of the database and specifics. So I can leave right now. I can post the voice to Sam to refer a bit on how the Rust implementation has been made for utilization of the GroveDB, and later on Ivan will cover how it also has been integrated with the JS part of the component.
Sure. I just did want to say something for the people that are joining us that don't know. We did have a few people that couldn't make it tonight. So in the previous, in some of the work that we're going to say and explain, it normally would be presented by other people, but not everybody could join. So we have about 3 people missing. Just would like to point that out. Okay, so as I said in the past, we are moving from JavaScript to Rust, and this is going to be a long process. So a lot of new code written is now in Rust, yeah. So because of that, some of the work this sprint was written in Rust, and the first 2 tasks are actually done by Wisdom. So is Wisdom? Yes, Wisdom, you're here. How about you explain the first 2 tasks?
Okay, hi guys. So the first 2 tasks are this serialization of contract field types and property field encoding for paths. So the JavaScript implementation of Drive communicates with the Rust side by sending a CBOR version of the contract. So in order for the Rust RS drive to be able to deal with this contract, it needs to first of all deserialize the CBOR contract into a valid type with all the necessary fields to be able to process the contract. So we worked on this sprint, and then property field encoding for paths is basically we need to store different data types in the in GroveDB. So dates, strings, booleans, floats, but we need to store them in a way that they are sortable through binary. So after converting the type to binary, we want to be able to sort it with the binary values, as opposed to converting the binary back to the type and then sorting it from there. So this would allow us sort without needing to do unnecessary deserializations. So we worked on those 2 this sprint. Over to Sam to talk about the rest.
Cool, thanks, Wisdom. The next 5 stories I worked on, and they're for people joining that they're kind of going to be out of context, because previously there was other reports that would make this a little bit more understandable. For example, the first one is add additional indexes based off of data contract updates. Well, in the previous sprint, we created indexes based off of data contract insertion. Now it's now, like for example, when you update a data contract, new indexes come in. we have to add those additional indexes. So it doesn't make as much sense as people that have been, inside of DCG for a while and been watching these videos, but I hope external people can kind of understand what that means. Deserialization into proper structure of query. So because we decided to build a secondary index structure that we needed for our new database solution in v22, and we decided to build that in Rust. And to do that, we had to implement some code that had already previously been implemented in JS Drive, but we had to kind of re-implement it in Rust. One of that is basically when you get in a query from the system, we need to properly deserialize that query. In previous sprints, we had the index structure that had been done before, so it just literally was querying data at this point. Except documents with protocol version. In a recent update, documents now have a protocol version prepended to them, and we just need to support that. The protocol version allows for us to change the deserialization format in the future. For example, let's say that in version 1, we use CBOR, but then in 5 years from now, we realize that it would be much more efficient to encode in a different way. Well, we can change it, and the version will tell us how to encode and decode in the future. So it allows our system to be quite, updatable. Let's just put it that way. Allow variable order of index properties in where clauses. This was actually quite tricky. So, for example, when you do an SQL query, you can put your where clauses in any order that match an index. So I'm going to do a demo later, and that's going to become a little bit more evident what that means. To do this, I basically find the best index matching this potential query. Oh yes, and querying documents with secondary indexes. That's the big thing. So now you can query documents in our new system. So the database does work, and I will show that's working. And just for people that don't know, why did you guys build a database? Probably is a good question. Well, there was no database, believe it or not, that could do exactly what we wanted, which is have any value proved in a special way. So there's I think Ivan will do a presentation shortly, and he'll explain what are the fundamentals of our database and why they're different from other databases. Okay, Ivan, you want to talk about these two items? Or should I just say, explain them quickly?
Yeah, go on.
Okay, so, these are pretty small. We changed our secondary index implementation a little bit, and the query validation still lives in the JavaScript part of Drive. So we just needed to update our query validation, and that's done. One of the big items for v22, what we still need to get done is we need to integrate GroveDB and the Rust part into the JavaScript part, and that's still in progress. So that's not done yet. So it's the only thing that we actually planned to do that was not accomplished. Let's go to the next slide. Now, there are a lot of things that we didn't plan on doing that we also did that kind of came up during the last 2 weeks. One of them was a starts with operator. So when you query things, for example, like give me people that start with the letter S, in your query to the system, you can do that. That's now done. An in operator with a subquery. So that could be something like, give me people whose first name is Sam, Tom, Susan, and whose age is bigger than 40. That now works. And another thing that was done was grouping range query operations. So for example, if you said, give me people whose age is greater than 30 and less than 50, that's also done. I'm just using an example with people, and but we could use any type of example, like pizzerias in the United States, or we could use any type of data system as an example. I just think people is easier to understand. And my demo, coming up demo will be on people. So starts at and starts after. This is actually a very big improvement over our current system. Devs in the incubator might be quite happy with this. So before, what had to happen was you queried for a certain amount. You said, like, give me 100 documents matching my query to platform, and it would give you back those 100 documents. And then what you would do is you'd say, oh, give me the next 100. But in the meantime, things might have changed. Something might have been deleted. Something might have been added. And when you add something, it's not so big of a problem because you're just going to get extra data again. But when you delete something, you might have, missing values, and it's not good. So instead, now we have starts at and starts after. So you basically, if you want to get more than 100, you take your last element, and then you just do a starts after using the ID of the last element. And then you can get like ranges much better than before. We also have an initial continuous integration. Thank you, Pasta. I also made a demo app for people to see. So one thing here, we did not plan, so kind of like a misstep on our side. We needed RS drive bindings, and this was needed for the integration on the previous task that we did not accomplish, the integration, and we didn't plan for it, and it's a pretty big work. So that's pretty much what we still need to do for V22 to be released. There's nothing really else other than like maybe one or two small tasks that we discovered today. Okay. Now let's move to next slide.
Yeah, thanks guys for the part. I wanted just to remind you, dear followers, to post some questions in the YouTube on our live. We'll do our best to gather majority of them at the end of the meeting and be able to refer to them. And now we will be going to a part covered by Ivan. It will be some kind of pre-work and pre-explanation of the data storage that Sam was mentioning. So I guess that I can leave the screen share, Ivan, to you at this point. And if you could get us through the secondary indexes document, would be really nice.
Yes, sure. Let's share my screen then. Okay. Do you see slides?
Yeah, everything's fine.
Okay, cool. So I would like to speak a little bit about the history and why we're doing all this databases and all the work what Sam just mentioned. So I would start with a little history on this. So we're going to talk about the second indices for documents. So first of all, what is the second indices? To be able to query documents not just by primary key, not by ID, but using the property values, for example, for profile, you can have like first name, last name properties. So you should be able to fetch these documents just using the value of the properties, like other common databases, right? Also, secondary indices allow us to enable uniqueness constraint on one or like several properties. So, for example, we want to make the some field security number unique, and we don't want other profile documents to have the same value. So we can create unique secondary index. And you can combine several properties into one compound index in case if you want to do more complex queries where you want to include several values, not just last name, but security number, for example, or age. So you can build compound indices. In previous versions, we used MongoDB to implement secondary indices, and it works in two steps. So when we get the query from client, request for documents, we first of all perform this queries in MongoDB, and we stored the indexed properties in MongoDB and get back the documents IDs, and then we using these IDs we fetch documents itself from the Merc. Merc is the authenticated database what we used previously. I'll talk about it a little bit later. So we need, like for all data what we're responding with, since we are working in trustless network, we need to be able cryptographically verify everything on the client side, if it's light client. So we need to provide the cryptographic proofs, not just data. And this approach with MongoDB, we were able to check that result set, the set of documents, what we get back for the query, the documents match this query. So they have this last name, Robertson, for example. We can check that, verify the documents actually exist in the state, the network. But the problem was that we weren't able to verify that actually the result set contains all existing documents in the set. So basically the masternode could, like malicious masternode could perform like a mission attack and just don't include some documents in your result set, and you never know they are or not. Another solution, what we consider it is, okay, we need to store our second indices in the Merc as well, because Merc is the basically authenticated data structure. It's a database based on data structure. It's a Merkleized key value storage. So like simply it's a AVL tree, Merkle tree persisted in RocksDB. And it's one big tree, and we can store not just documents there and contracts, but we can also store the secondary indices itself. So to do so, we can encode the indexed property value in a special way. So after we can iterate from the keys and find specific documents doing this. Yeah, for example, if you have a query like give me the documents where last name is Robertson. We can just go through the keys, iterate through the keys with the prefix, and which point to specific contract, document type, and index, and find the all keys which include the Robertson. And also we need to include the left boundary and right boundary. So having this, it also could be gaps in the middle, technically. But with proofs like that, we can actually verify that all required documents are provided to the client. So there is no omissions. It's kind of simplified a little bit way to explain. Unfortunately, I wasn't able to accomplish all my slides, so they probably gonna be less nicer and shorter. So in this slide, you can see the tree, the AVL tree in the Merck. So we have a Merkle root hash at the top, and you might be wonder a little bit why we have the items in the middle of the tree, but the difference of AVL tree and dense Merkle tree that the items are stored even in the intermediate nodes, not just at the leaves. So yeah, here we can see that in this tree we have identity with some ID and value, serialized identity underneath, and also we have contracts and another identity. We have another contract, and we have the document, what we're requesting for, and the secondary index, the key, which represents secondary index for last name Robertson. And this, so basically iterating through the finding this key, we can build the reference. So actually it includes ID, document ID itself. So we can fetch document, serialized document from the tree using this ID. So we go through the secondary indices, and then we fetching as a second iteration, we're fetching the documents by ID, but through the same database without MongoDB. This approach has downsides. First of all, since we store everything in one tree, this tree is supposed to be pretty huge, right? And the iteration through the tree to create the proofs, and also the proof size, because the bigger tree, the bigger Merkle path you need to build up to the root hash. They very depends like on the size of the tree, so it's not really efficient.
Sorry, your screen was not refreshing. It did refresh now. It was the same issue on YouTube, but it's good now. Never mind. Please continue.
Oh, thanks. So, and the second thing is that we need to add some prefix before each keys, because keys must be unique, and these prefixes should point to specific data contract, document type, and the index, right, to do these iterations. So this duplication of information in every key, because you could have like many of them, right, many documents with the same last name, it's kind of not really efficient as well. So it's kind of extra space, like in the proof. So it's for network throughput, right, and also in memory and in the cache and the disk to store data. The third problem that each update of the document, we need to go to the all related keys, like the secondary indices, and update the hash of the value of these keys to update the document hash there. So it's a lot of operations to update. So, and as a solution, we had we discussed this idea like, I know, like 2 years ago maybe, Sam mentioned it first time. And recently we found a paper which kind of prove the idea that it's much more efficient. Is just instead of having one big tree, to have like multiple trees, so you can split specific data according to your queries, how you gonna do it, to the separate trees, and combine these trees into multiple levels. Yeah, so the proof size will be smaller because you don't need to get all these intermediate nodes for Merkle path, and also it's more efficient for storage. I think eventually it will be nice to calculate the difference, real difference in these two approaches. So to implement this hierarchical authenticated data structure database, we built GroveDB. You heard about it already. So comparing with the Merk, GroveDB allows us to combine these trees into each other, and potentially we're going to implement other types of authenticated data structures, not just the Merk tree, not just AVL, but dense Merkle trees and the authenticated linked list and so on. It depends on the use cases. So also we have a different, so in a Merk you can store only some specific binary at the value of the key at the element in the tree. With GroveDB we can store references, trees, like to put one tree to another, to build this hierarchical structure in like normal values like in Merk. This is very important, and I'll show you now why we need these references and trees. So first of all, in the GroveDB we have a root tree. For now it's the hard-coded type dense Merkle tree, but I will probably change it later. And this is initial structure, what we have in the drive. You can see the leaves here. It's identities, contracts, public key to identities to allow us to fetch identities by public key, and some miscellaneous data like spending asset logs and probably something else in the future. So we didn't put it on the first level just to decrease the size of the proofs, because this identities, contracts, and public key to identities is the most popular things what we're fetching. So yeah, some optimization. And under identities, you may see another tree which will contain the identities itself by ID, and the same when we have a tree for contracts and the tree for public key to identities and so on. So it's kind of nested hierarchical structure. Yeah, that's where slides become less nicer. I will try to explain what you see here. So I tried to represent the contracts tree. This one, what you see in the root tree. So below it goes like this. In the contract tree, we have elements, which is with a key contract, which represents contract ID. And under each contract ID, we have a subtree, this Merk, where we store under the key 0, we store the contract itself. And the key 1, we store the document types. So, and the documents related to this belongs to this document type. This structure allows us to make proofs reduce the proof size. So basically, when you fetching, give me like documents for type profile, the proof size will be much lower because it basically almost the straight up to the root. If we define the, so you can see under the key 0, there is a documents itself. And we also able to fetch not just documents, but documents and contract together. Or in the future versions, we're gonna, so basically you don't need to fetch contract and then do another request to fetch documents. You can do it together. It is one request. And also in the future, we probably are allowed to fetch not the contract, but the contract hash, so you can verify is the contract you already have on the client changed or not. So and if it's changed, you can fetch the new one to validate documents and verify them. So if you define the indices for the profile type, it will be additional subtrees underneath. For example, we have an index on last name. On the next slide, I'll show how it looks like. So we use the property values as in other previous approach, what we discussed with Merck, and we encode them in a special way so we can iterate through them and get data underneath. Sam will show how it works in his demo. So, and under the values of the last name, we have a tree structure as well with the reference. It's not the documents itself, it's a reference. The ID is referencing to the documents in the previous tree. So we don't duplicate data, and it's pretty convenient on the in a drive when you use GroveDB. We don't need to do additional calls. So reference automatically get the data from other trees, from other keys. So in case of compound index, when we have, for example, last name and first name, the last name or the first name index will go under the Robertson tree. There is you see the next index of property. Sorry, I didn't have time to represent the structure completely. So I hope next time I will be able to accomplish it and represent it better. That's it. So if you have questions, please leave this in the YouTube chat, and we'll be able to answer them after the presentation. Thank you.
Yeah, thanks, Ivan. That was an amazing presentation. I'm not even sure that everybody inside DCG even knew all that stuff before. I would like to say a few things. I think you're still sharing though.
Yeah, stopping this.
I would like to say a few things for people who might not know. You know, in a decentralized system, proofs are everything. Having somebody just say, hey, this stuff exists, like it means nothing. You actually, for every data that you get back from a decentralized network, it has to be proved. And there are a lot of, let's say, systems out there that call themselves crypto that don't actually prove their data properly. And there's tons of issues like that. In our system, every data that you get back will be proved and will be efficient. And that's really what we're trying to build, something that you can use on your phone, that you can check any like app that you might have, that you'll be able to download your data and efficiently prove that all the information that you're getting back from DAPI is true, and is not only true, but it is all the data that you're supposed to get back, not just a portion. So just want to say that very quickly. And right now I do have a nice little demo to share with you guys. Before I do the demo, I just wanted to share what the actual contract looks like for the demo I'm about to present. So just for if we have any incubator devs that have worked with Dash platform contracts. So basically for the demo that I'm about to do, I made a little contract called family. And I don't know why I called it family, it should be called person, but the following indexes exist. There's an index on your first name. There's an index on first name and age. There's an index on first name and last name. There's an index on first name, middle name, last name. And then there's an index starting with age, first name, middle name, and last name. And there's also an index with age. So I just wanted to quickly share that before the demo. And now I'm going to move on to the demo.
Sam, did you want to show also, like bring the perspective of functionalities in GroveDB? What has been done there before you show the demo of how it's working?
I think that we should just transition into the demo right now and then move on to GroveDB, because it will explain kind of what Ivan just shared. I think it's a better.
Yeah, and also it will be more understandable why do we need this functionality in GroveDB.
Mm-hmm. Now, what I'm going to present right now, a lot of people are going to be like, wait, most databases do that. Yes, most databases do that, but they don't have the proofs to go along with it. So the fact that we're able to replicate a normal database functionality and at the same time offer proofs is actually quite good. So I basically made this little program. It's just a terminal program. It's nothing beautiful. Made it in a few hours. It's called Welcome to the People RS Drive demo. It allows you to do a few things. So for example, you can populate with random people. So I'm going to populate with 10 people. And one thing that I'd like to point out is that this demo it has two things, making it a little bit slower. It will not take 10 seconds to insert on our live version. We just had a 15 times speed up that was just made by Wisdom. So it will be 15 times faster, plus it will be released, which is 30 times faster. So it should be whatever, 450 times faster than what I just showed. Don't quote me on that, but that's probably the right number. Okay, so we just populated with 10. Now we can see the 10 people that we just added. So we have these 10 people, like Amy Rufus Pembers, who's 16 years old, Annalise Tripp Hamish, who's 80, and the very beginning is their ID. So as you can see, this is now sorted by first name, which was the default, I believe, because it was the first index. But we can also just do all, we can sort by age, for example, here, right? And now these elements are sorted by age instead. As you can see, 3, 7, 16, 26, 24. Then we can also, the system also works with limits. So I'm just going to quickly show that. Let's say sort by age, and we're going to limit to 4 elements. And I would like to point out that all of this data is provable. So you can actually say, hey, give me people from give me data from a certain contract and only give me 4 elements that I care about, like the first 4 elements, and then you get only back the first 4 elements of whatever query that you send to the system. I do not yet have queries done, SQL queries, because it is, I have to, type in SQL, and currently Dash platform works with a different language than exactly SQL. So we do have that functionality inside of Drive. It's just not yet in this demo. But I'm going to show how the indexes work. So as you guys can see, there are these various people. And what actually becomes interesting is, for example, if 2 people have the same first name, and let's do that. So let's insert somebody. Anya, I like that name. Anya Beatrice, I'm just trying, my random number generator in my brain is not working very well. Let's see, Perry, and let's say she is 33. And then let's insert another one, Anya, Beatrice, Anya Meadows, Carol, whatever, and 44. Okay, and now let's see them again. So we have Anya, Beatrice, Perry, Anya Meadows, Carol, and Anya Simon Perrin. This is actually super unlucky because the ages are already in order. So we have to create another one. It's based off of the ID on the left, where you see like the ID starts with 3 right here, and then it goes 6, and then it goes F. This is completely random. So let's just create a few more until we get some ages out of order. Teresa, Tate, 7, and let's do all. Yeah, so okay, so Anya, Teresa, Tate, as you can see, it's out of order for the age. Now, we did have a data contract, which was first name, age. So I'm going to quickly show that works. Sorry, we did have an index, which was first name, age. So based off of the index that we have, we're actually able to query based off of those indexes. So this would be first name, age, right? And now they're sorted. Now, this is not, the sorting is actually not happening locally. It's not happening in memory. This sorting is actually coming directly. They are pre-sorted on the system based off of references, based off of the indexes. Now, what is actually cool, and I'll show this functionality as well, is as you can see here, we have when we populate by age, we see there are 2 people that are 44. Now, there was one index which was age, first name, middle name, last name. And what we'd like to do is we'd like to sort by age and then first name. Now, it does not actually match the index, but it will still work. Now, the problem actually here is that they're already sorted, the ones at 44. So we're going to create a new one. Hopefully, that will be out of order. Insert. Well, I'll just put my own name, and I don't have to think about it. I'm not 44, by the way, but for the sake of the demo. Okay. Samuel Abram Westridge, and I'm still, oh, no, I'm not in order. So it should be Anya, Vivian, and then Samuel if I wanted the right order, so I can actually check that. So I do age, first name, and I'm just going to do it like that. And now you guys will see that it is in the right order. And this is actually pretty hard to do on a provable database by not using all the indexes. And it works with the complex tree structure that Ivan presented earlier. Now, somebody on YouTube did ask for us to present our roles. I'm just going to present, I'm the CTO of Dash Core Group. My name is Samuel Westridge, and previously Ivan was speaking, who is a principal developer in the platform team, which is our equivalent to tech lead. So he's the tech lead of the platform protocol team. And previously we also had Wisdom speaking, who will be speaking again, who is a developer in the GroveDB team. And with that, that's the demo that I wanted to present. I do want to just explain to people that this is not an interface at all for Drive. This is literally just a demo that uses RS Drive. So nobody is ever going to use this. This is literally just a little demo that uses one of our libraries that we've just created. Okay, so with that,
sorry, Sam, I just was promoted.
no, you had that role. Okay, so who, I have to stop presenting. Maciek, you continue the presentation?
Yeah, sure, I can continue. And I was thinking actually we should be moving on to the GroveDB slides, but like I'm not sure, guys, if it's reasonable while having this kind of comprehensive update from Ivan and the presentation from you. Maybe we can jump out to the directly to the SDK part, since also we have like an hour has passed.
People have never seen one before.
Okay, so just sure. Okay,
if
so
people
just quickly,
get bored, they get bored.
Yeah, okay.
Oh, okay. One thing really quickly, I do want to answer Leon. Yes, we can also prove that stuff does not exist. So, you can also prove that, for example, if you say, hey, is there anybody with the name Sam in the system, you can prove that there is nobody with the name Sam. Okay.
Okay, Sam. So actually, I think that I should be letting you speak, continue to speak, but because we have some few slides around particular functionalities of the GroveDB, which are just mainly aligned to typical database operations. Like Sam was saying, there was big focus and big emphasis on making it optimal and making it fast enough. And aside that, transactions support subqueries, range queries, lazy loading of subtrees. That's like actually in review, but
wait one second, Maciek, you're sharing a black screen.
Sorry, excuse me. I guess we can see the presentation, right?
Nope. Nope. But I can share if you want.
Yeah, okay, so go ahead. Maybe you have...
Okay, I'll just share it.
Stop sharing, Maciek.
Sure, thanks for notice.
There we go. Is it sharing properly? You guys see my screen?
Yes.
Okay.
Yes, that's fine.
Yeah. Sorry. Here we go. And I'm at the very, okay. So yes, who is going to start this one again? Yeah, Eugene. Is Eugene on the call?
So are we starting first?
No. Eugene
no,
wasn't able to participate.
Oh, okay, no problem then. Ivan, are you presenting? Sorry guys. Okay, Ivan, you want to talk about the bindings then?
Yes, sure. It must be a special slide for that somewhere below.
Oh, yes, actually we do have slides for these, sorry. So actually, no, then Wisdom, you start. Lazy loading of subtrees.
Okay, can you go 2 slides back?
Oh. Sure.
Okay.
Sorry.
Yeah. So we implemented range after query item, which we added to Merc to allow to retrieve items based on new query inputs. So the range after item basically excludes the first symbol and then returns everything after based on some specification that you put in. So we had 3 different types: range after 2, and range after 2 inclusive. So imagine there's a set of alphabets, so just A to Z. If you apply a range after on that set, starting at A, then the result sets would basically exclude A and return everything in the set. So range after 2 from A, M would exclude A and return everything up to L. So it's going to exclude M also. But then there's range after 2 inclusive, A, M, that excludes A and then returns everything up to M with M inclusive. This is done and merged. Can we go to the next slide? Okay, so we also had to implement an isEmpty tree method. We're basically giving a path to a tree. You get a bool that tells you whether the tree has any elements or not. So this is needed by Drive to delete trees that are empty and also delete metadata regarding trees once they are empty. Next. Yeah, so lazy loading of subtrees. We realized that once you insert documents, as the size of the documents becomes really slow, so the insertion process was just too slow, and we had to figure out how to optimize the process. So the solution we came up with was lazy loading of the subtrees. Before, all the subtrees were stored in memory, and then on each update, they had to be serialized and stored on disks. Process just took too much computational effort. So currently we have implemented a solution that loads subtrees only when you need them and then discards them once you don't. So this brought like a 15x improvement in performance. So it's currently in review, and once that is done, it will be merged, and we'll have that on master. Okay. Sam?
Yeah, sure. One thing that was also worked on was recursive subqueries. This is actually needed for DashPay app. When you actually get your contacts that have recently updated. So you send a request to the system saying, hey, for these contacts that I'm currently looking at on my screen, tell me which ones have updated. So it's like where the ID is in this set and updated greater than the last time you've looked. So yeah, so this was actually pretty interesting to build. We won't allow, due to the complexity of returned proofs, recursive subqueries that don't have an in. For example, we won't allow queries such as where name greater than Sam and age greater than 40. And the reason behind that is you could quickly attack the system. But we will allow equality clauses and then a range query at the very end. So I hope that people can kind of understand that. It's a little bit more technical. Yeah, so what's next? Coming up, this is not going to be in V22. We are going to collect the operations for multiple subtrees into a single batch. we're going to do chunking. Chunking is basically decomposing the database into multiple parts for quick sync for new nodes that like just start operating. Yeah, like imagine your state database, state GroveDB has 1 terabyte on it. You make little chunks and you send those chunks, and the person actually receiving the chunks doesn't have to get them from one source. Pretty much like torrenting gets them from like many sources. And then the proof system. So the proof system exists, but the actual proofs were not finished for every single type of query. So we are working on that. We will be releasing V22 without the proof system because we just need to get it out. We need to have people start using the system. Proofs will be in V22.1 shortly after, probably like 2 weeks. 2 weeks later, we'll do a quick update. It does not require it's not a version change to enable the proofs. It is a version change. It's not a major version change. It won't break the previous system. Okay, so now we're moving on to SDK, correct?
I think, Sam, you skipped the slide. The previous one's supposed to be about the Node.js binding. Oh,
No, I don't see one.
Oh,
I did. Sorry. Go ahead, Ivan.
No problem. Yeah, me and Evgeny worked on the binding for Node.js for GroveDB. So the idea is that GroveDB is written in Rust, and we have JavaScript drive, it's written in JavaScript, and we use a Node.js runtime to run it. So basically the goal is to use this Rust GroveDB database in JavaScript in Node.js. So for that we had to create a binding. It's basically this bridge between Rust and Node.js, and the special framework is used for that. It calls Neon. We implemented that, and some additional methods were required, and we updated the CI to automatically create the pre-builds for different architectures and platforms. So you don't need to compile GroveDB and everything every time when you install this npm package. It's supposed to contain pre-builds. Yeah, I think I accomplished. Yeah. So that's
okay,
it.
let's move on to SDK.
Sure.
I'll stop sharing. Maciek, you want to try again?
Yeah. Let's continue from my side. I guess that it will be okay. And just please confirm me that you can see the presentation and you can see the slideshow right now. Oh, that's a shame. So maybe let's not do any.
I can do it again.
You can do it again. Exactly.
Yeah, sure.
Demo, live presentation effect.
Sorry. I need the link though.
Yeah, grab it.
Did you send it to me?
Mm-hmm.
Okay. Sorry guys for this technical technical issue. Okay, here we go.
Okay, thank you, Sam. Hello, everyone. I will start with a quick introduction. My name is Igor, and I work in DCG since October 21. My main focus in the project is SDK. Let me share my screen. Do you see it well? Please, someone confirm that everything is okay.
Yes.
Okay, thank you, Robert. I will start explaining the first bullet point in the slide. It is related to the Dash SPV. For those who is not aware, SPV stands for Simplified Payment Verification and serves the goal of transactions verification without the need of downloading the whole blockchain. This is a crucial feature for lightweight clients such as browser-based apps because they cannot afford downloading lots of megabytes of chain data. Since SDK running in the browser cannot make P2P connections, it interacts with a set of Dash APIs that provide friendly way of interaction with the Dash core nodes. I spent this week implementing functionality that obtains the whole chain of block headers from DAPI and validates blocks headers against each other. In case if some DAPI node fits clients with headers containing malformed or malicious information, verification of such header fails and client attempts to obtain them from other DAPI nodes. And hence, we have a reliable and secure way of obtaining chain data from diverse set of participants. And if something goes wrong, client automatically detects that and tries other ones. The plan for upcoming weeks is to integrate this functionality into the Dash wallet and start using chain of verified headers together with the transactions. And I'm not going to go in detail about the rest of bullet points. They are rather technical and internal, but mostly these are bug fixes for functionality related to the instance and feature of Dash, which you can check out in our documentation, and also improvements of the CI process. So that was pretty much it. Thanks for the attention, and I will hand it over to the Mikhail, I think.
Yeah, sure.
Oh, sorry. Well, one more thing. Yeah, I'm sharing my screen right now before Mikhail, you proceed. Yeah, here is a relevant test case that performs this sort of filtering out of malicious actor that performing a man-in-the-middle attack. Here you can see that the SDK starts reading the block headers. Here I insert the bad block header, which is supposed to trick SDK client. And eventually everything goes to normal and client retries the fetch right ones. And this is the test case, which is currently merged in our master actually in master V22 of the platform. So yeah, now that's it.
Thanks, Igor.
Thank you.
Can you guys see my screen?
Yeah, I can see. Yeah, but can you please go back to the slide with, yeah, sure. Yeah, this one. Thanks. So yeah, during the last sprint, we was working on the improving performance of getting some block headers information. So we changed some calls. We reduced some calls to the Dash core node. We changed some calls from the get block on get block stats. We replaced this call because the get block stats is more like improved call and have better performance than get block. And yeah, that improved the performance of the DAPI itself, and that causes the loading of the new blocks and so on. So, and also we started working on the caching block headers in DAPI for future use. So the thing is, currently, when multiple connections start requesting some block information, transaction information, it gets requested from the Dash core itself. But if the same if different clients trying to fetch the same data, it will be requested multiple times in the current situation. So we are going to cache that data like block headers, transactions, and then return this data to the client from the DAPI itself, not from the Dash core node. So that will improve the performance of DAPI clients and also prevent some denial of the service attacks when you could just open a lot of connections to the DAPI node and start flooding the whole DAPI node. So yeah, that's it from me. Alex, I guess, is the next one. I'm not sure he's in the call right now.
He's not.
So
he is.
Yep. Hello,
yeah.
everyone. So I'm Alex. I help with the development of the SDK. So on top of what we previously described, we also make good progress with the delivery of derivation path registration and the implementation of DEEP15, which bring DashPay to the SDK. This basically enables developer to register any derivation path to the wallet part from a plugin. It allows a Bloom filter to be extended with additional address such as those from DashPay contact, and also brings availabilities for the SDK to listen for contact request, perform new request, and obviously pay to a DashPay contact. We already released an update to the storage and persistence layer. It enables faster and better handling of pre-synchronized information. It speeds up the time to load a pre-initialized wallet, and it also addresses some issue with exporting and importing the state. This feature also had the handling of contact and identity synchronization. This is as per DEEP16 specification. And to simplify, this feature allows Dash.js SDK to find your identity, your contact, synchronize payment, including those from your contact. And obviously, developer will have full access to all those features to help with their integration. So that's basically what these two dots represent. That is it for me. Thank you, everyone.
Yes, Maciek, you were going to talk about this, correct?
Yeah, actually, just a few words about the plans for the upcoming time for SDK in general for the whole platform service before we go to the Tenderdash. So obviously, the ultimate goal is to finalize V22 and deploy the DevNet and just a moment after it the testnet and be sure that all is stable and operational. Integrate all of that stuff. Enable query proofs. So as Sam and Ivan were mentioning, this proof system is still to be finalized, but after the version 20 deployment, client SDK improvements. So as Igor, Mikhail, and Alex were commenting, on top of that, we have lots of stuff, a lot of important improvements that were discussed with mainly with Incubator. That we want to find some good timing for them and bring fixes like as just in following weeks. DAPI SPV to be continued as gentlemen mentioned previously. And I guess at this point, Sam, if you could back us up with the presentation of Tenderdash, and we could give voice to Łukasz and Dima to cover this a bit more.
Yeah, sure. Give me a second.
And just in the meantime, I wanted to remind you to feel free to post any further questions on YouTube. We're seeing them already. There's quite nice selection of them. Also, any feedback for the whole team and for the presentation might be very helpful. We indeed want to uphold this practice to just expose what's going on in the project, what teams are doing, and this feedback might be really crucial for us.
I need the presentation link.
Maciek, can you try sharing yours?
I found it.
Okay.
Found it. And I do want to apologize. This is the first time we've done this live.
No worries. We can do editing after.
Okay, Lucas, you want to go?
Yeah, I can start. So hello, my name is Łukasz. I'm a developer working on Tenderdash, and our plans were to go through 3 points. First one was to prepare to release Tenderdash 07 together with the whole platform. Second is we are working on quite a big task to backport Tendermint 035 to that will become a new release 08. Tendermint is our upstream project. Maybe I will just add a few words about what Tenderdash is. So this is a consensus engine. It's a fork of the Tendermint project, and the basic task of Tenderdash is to ensure consistent state between various nodes. So what we basically do, we generate blocks, we sign these blocks inside Tenderdash, and we ensure that the platform has a consistent state across all the nodes. And task number 3 was also related with the backporting. So basically to take all our work done inside 07 and merge that into 08 version, so the new one that we are working on. That's pretty much it when it comes to what we planned. And on the next slide, we can see that we prepared several automations to be able to quickly release Tenderdash 07. And we did some scripts that will prepare release for us. We reviewed and bumped version numbers for ABCI apps. So for our communication protocols, that script also generates a changelog, and then we have a manual step where we can improve that changelog and accept the release. So this is the first part of our work, and the second part of things done is Dima. Do you want to go next?
Yeah. Hello, everyone. I'm Dmitry from the Tenderdash team. So yeah, the current status of backporting Tendermint on the Tenderdash version 0.35. Well, according to this version of backport, the scope of the topic is the same, and because we didn't have any other priorities since last time, and all our effort was focused on backporting of this version. And the current status you can see on the screen on the slide. So basically, we're already almost done. The E2E test was done. The unit test is also done, but currently we're working on fixing the issues in CI, because currently everything works locally, but when we try to run them in the CI, sometimes they fail, sometimes not. It's kind of flaky. And we try to investigate it and fix it. I hope next week we'll be done Although a lot of effort was already done, like fixing letters, makes the tables and so on. Yeah, I hope this big topic for us will be done in next or probably 1 week. Yeah, Lucas.
Yeah, and then the third thing we were working on was to continue backporting. This time it was backporting of the features that are new in 0.7, and this we are backporting to the new version that will be 0.8 and will contain changes from Tendermint. And here the status is very similar. We are done with the source code and unit tests and still waiting on end-to-end tests. So basically this, we just met together on the E2E tests topic, and we'll be working on this in the current sprint. And once it's done, we will just release 0.8 dev1 pre-release version and test it on the devnets to see if everything works correctly. If the backport was successful, we'll do extensive tests, manual testing, and integration testing on the devnets. So that's more or less the plan for this task. And I think that's pretty much it when it comes to the big tasks. On the next slide, we can see that we merged some small merge requests and updated dependencies. I will not get into details. If anyone is interested, feel free to get in touch either on GitHub or on comments. And interesting thing that is described on the next slide is that we are looking forward to get the Tendermint ABCI++ protocol implementation. What is it about? The biggest value from this is the same block execution mechanism. Right now, to get everything confirmed, to get any changes in the state confirmed, we need to wait for new blocks, and it adds some delay to processing. Inside the platform, we have some workarounds for this issue, but the actual solution is to get ABCI++ protocol implemented. And the upstream Tendermint team is working on that. They prepared a specification. Anyone interested in that can take a look and comment. And the Tendermint team declared delivery by the end of Q1. And there is also a board where we can track progress. And depending on the delivery, we will plan our next steps in this area. So that's something we are really looking forward to get from the Tendermint team. And I think that's pretty much it. When it comes to what's next, we plan to finally release 0.7, which is basically ready. We are just waiting for the platform to also be ready to release and do one full release of all components. That's the plan. So it shouldn't be any work at all on the Tenderdash side. And we need to continue the Tenderdash backporting tasks. And two future tasks. First one is the same block execution I just mentioned. And second is the inter-blockchain communication implementation. These topics are in plans or some initial research phase, but I hope to get there pretty soon. And that's it on our side, I believe. Sam, anything to add or any questions? If there are any questions, feel free to ask on the chat.
Yeah. Thanks, Lucas. I did want to quickly say, just for people who don't know, Tenderdash is different from Tendermint because it has like a lot of stuff that we needed for our system that just Tendermint did not have, including threshold cryptography and the ability to like prove the state just with one signature instead of a multitude of signatures. It's actually based off of SBFT, which is Scalable Byzantine Fault Tolerance, instead of PBFT, which is Practical Byzantine Fault Tolerance that Tendermint is using. So it's actually quite diverged from Tendermint, but we still, get free features from Tendermint from upstream. I think that we don't have much time to talk about it more this time, but most likely in a future sprint review, we will go into, make maybe a presentation on what is different in Tenderdash versus Tendermint. I also did want to say one thing. In one of your slides, Lucas, you have validator communication. Just so people from the community understand, we do have validator communication already between validators, but this is actually a direct connection between validators to speed up the system and also to prevent something called validator islands, where validators have different nodes in between and they can't communicate. They can't reach each other because the nodes in between don't relay the messages. Okay, well, that's it for our first live review. I hope people enjoyed it. Now we will be going on to questions, I think. So, do we have any questions, actually?
Yeah, there were a couple of questions collected during the call. I think that some of them were already answered while you were talking, but what is remaining is, for example, will it be possible to register a username via desktop Windows client? Probably it's more towards Pasta and the core team.
Oh, the desktop Windows client.
Yeah.
Currently, that's not set for MVP, no. But we should be able to register a username through the SDK, and hopefully in partnership with the incubator, we might have a widget available on mainnet launch to be able to easily.
Yeah, thanks. There were a couple of comments about the stream itself and the update. People are pleased with it and asking, will these updates be scheduled in the future?
So, sorry?
People are asking if those updates will be scheduled also in the future.
Oh, yes. Well, we're planning on doing them every 2 weeks. This one is going to be probably longer than any other one because there's a lot of context where we kind of have to explain what we're explaining. But if you pay attention and watch it every 2 weeks, you're going to start like understanding the story of, okay, this week we did this, then it kind of is like a building, and you build like layer upon layer, and then the understanding should flow from previous weeks. Again, every 2 weeks.
I believe the rest has been responded some, unless I missed anything. Leon, any questions missing? That's all. Okay.
I think Ryan Gould asking about high-level overview for Dash platform, and also when 0.23 will be released.
Why did you have to say something? Yeah, so I don't know what let me see the question for the high-level overview. A very high-level overview of what Dash platform is trying to accomplish. You know what? Let's leave that for 2 weeks from now, and we'll make a little presentation, Ryan. And it will also give you a reason to come to the next one. No, I know it was Dash platform, but we're really over time. The when 23, so we can expect version 23 about 2 months after version 22 is released. Version 22 should be released, as you guys saw. There are just a few more things in progress. What were the orange bullet points? And then we just need to test it on a DevNet for a few days, and then we're going to release V22. So, and then V23 probably 2 months later. V23 is our last version. Well, not last version. It's the last version with new features. After that, it's pretty much just running it on testnet and making sure that everything is stable.
Yeah, thank you, Sam. I think with this, we can wrap it up, right? Thanks again for all of the information provided. I think it's the first from many other exciting sprint reviews that we will host and share with our community. And once again, thank you everyone. Sam, Maciek for facilitating the call, Igor, Wisdom, Ivan, Pasta, Alex, Łukasz, and Dima for participation and sharing information. Thank you, Leon, for assisting with the chat. Thank you for all of the participants for your support, for questions, for comments that you have provided during the call. The call will be recorded and shared on our YouTube channel. So if you want to review it or check additional details, please do so. It will be there. If you are having any questions, you can reach out to us on Discord channel or on the forum. We will be more than happy to respond to your requests and questions. With that, thank you very much and have a good rest of your day. Bye, everyone.
Bye-bye.
Bye-bye.